Good day, everyone. Now we'll be discussing the Egyptian mathematics. When you hear the word Egyptian mathematics, what comes first in your mind? Maybe some of you would say pyramid or mummy. This photo shows the pyramid of Giza. So let's now explore about the history of Egyptian mathematics. The Egyptian and Babylonians were the first to use mathematics beyond the country. Both cultures developed mathematics that were similar but also distinct. Based on the papyri, we have few Egyptian math sources. Indeed, much of our knowledge of ancient Egyptian mathematics comes from two papyri, containing collection of mathematical problems and the resolutions. So first we have the Rhine mathematical papyrus was bought in Luxor in 1853 by A.H. Rhine 1650 BCE. But written much earlier, it's 18 inches long and 13 inches wide. An instruction manual in arithmetic and geometry, the Rhine papyrus show us how multiplication and division was done around 1650 BCE, as how to solve first linear equations, as well as arithmetic and geometric series are also demonstrated. Second is the Moscow Mathematical Papyrus. The Moscow Mathematical Papyrus was purchased by V.S. Golenechev in 1700 BC. It's 15 feet long and 3 inches. Wanna know what papyrus looks like? Papyrus, the ancient writing material, is made after the plant which is made. The cyperus stalk, which is cut into thin strips and stuck on the top of each other. The result was smooth, thin, cream-colored papyrus sheets, normally 5 to 6 inches wide. It is inked with brushes or styli, reeds with rush tips.
Counting and arithmetic basics. Let's now proceed with the basics in counting and arithmetic. Egypt used decimal counting, though non-positional. It can handle large numbers compared to the modern system, which are positional and by nature allow for the large numbers. Counting and arithmetic basics. Decimal numbering with 1, 10, 100, 1000, and 100,000. Symbols grouping and regrouping. Accomplished addition. Binary multiples were used for multiplication and division, with two expectations. Only unit fraction are allowed and all other fractions. The sum of unit fraction was required. Ancient Egyptian hieroglyphics numerals. This is an example where we start with a numeral with the higher number up to the lowest number. For example, we started with 2 coils of rope, which is equivalent to 200 plus, 4 heel bone, which is equivalent to 40, and 9 rope, which is equivalent to 9. When we add them together, we will get 249. Ancient Egyptian hieroglyphics numerals. This picture shows the ancient Egyptian hieroglyphics numerals. It is thought that the Egyptian introduced the earliest fully developed base 10 numeration system at least as early as 2700 BCE, probably much earlier. Written numerals used a stroke for units or 1, a heel bone symbol for 10, a coil of rope for 100, and lotus plant for 1000, as well as other hieroglyphics symbol for a higher 10 up to a 1 million. However, there was no concept of place value, so although a million required just 1 character, a million minus required 54 characters.
Operation numbers. Addition. In the Egyptian, addition was used in groupings when you write the numerals you needed to write it by group, and still start with a numeral equivalent to the highest number at the lowest number. Division is basically a binary. Example, if they need to divide 2 of the loaves among 5 people, They would first divide two of the loaves into thirds and then three loaves into fifths. Then they would divide the leftover three from the second loaves into 5 pieces. Thus each person will receive 1/3 plus 5 plus 1/5, which total repeat of we would expect. Multiplication is basically a binary. Multiplication works by repeatedly doubling the number to be multiplied on one side and the other essential. A binary factors multiplication like a modern computers. The corresponding blocks of counters on the other side were used as a kind of multiplication reference table. First, the combine of powers that adds up to the number to be multiplied by was isolated, and then corresponding blocks of counters on the other side, you'll get the answer. Example, to be multiplied 3 by 6 to solve this. We take the combination of blocks of one side, which adds up to 6, multiplied by 2 plus 4, and count the corresponding blocks on the 3 side, which is 6 plus 12 to give a total of 18. Fraction. Egyptian allowed only unit fraction with just 2/3 and 3/4. All other fraction must be converted to unit fraction. The symbol for unit fraction was flattened oval above the denominator. In fact, the oval was sign used by Egyptian for the mouth, in case of the volume measure he got. The commonly used factor parts of 1/2, 1/4, 1/8, 1/16, 1/32, 1/64 were denoted by parts by symbol for the R's I.
Circle. The Egyptians approximated the area of a circle by using shapes as area they did know. They observed that the area of a circle of a diameter 9 units, for example, was very close to the area of a circle of other diameter could be obtained by multiplying the diameter by percent and then squaring it. This gives an effective approximation of a pi accurate within less than 1%. Pyramid. The pyramid themselves shows the Egyptian mathematicians' sophistication. Leaving aside claims that the pyramid were the first known structure to use the golden ratio 1:1.618. There is an evidence that they know the formula of pyramid's volume, 1/3 times the height times the length times the width, as well as the truncated or clipped pyramid. Triangle. Long before Pythagoreans, they were aware of the rule that the triangle with 3, 4, and 5 units yield a perfect right angle. Egyptian builders used ropes knotted at intervals of 3, 4, and 5 units to ensure right angles of their stoneworks. The 3, 4, 5 right triangle often referred to as Egyptian.